Good morning and Assalamualaikum. My name is Azatu Shahira Busura. My metric number is 83354 from Faculty of Computer Science and Information Technology from Computational Science. Today, I will be presenting my final year project 1 titled Smart Pet Care and Veterinary Service Management System, which is supervised by Dr. Cynthia Konmui Lian. For today's presentation, I will begin with an introduction to the project, followed by the literature review where I discuss existing system. Then I will explain about the requirement analysis and system design, including the methodology used. Lastly, I will conclude my presentation by summarizing the overall outcome of this project. I will start the chapter 1, which introduces the background of the project and explain the motivation behind the developing of the system. Nowadays, pet ownership continues to increase, and as a result, the demand of veterinary service is also rising. However, many veterinary clinics are still using a manual appointment booking and paper-based medical record. This often leads to problems such as missed appointment, difficulty in tracking pet medical history, and inefficient clinic workflows. Communication between pet owner and veterinary clinic can also be slow and unorganized. Therefore, this project proposed a smart pet care and veterinary service management system to improve appointment management, medical record accessibility, and communication between all users are involved. There are several objectives for this project. First, the project aims to design a smart pet care and veterinary service management system that can also support daily clinic operation. Second, it allows pet owners to manage their pet profile, appointment, and medical records digitally. Third, the system helps vet staff manage and approve appointment requests more efficiently. Lastly, it enables veterinarians to secure update diagnosis and treatment information after each consultation. In terms of scope, this system involves three main types of user, which are pet user, vet staff, and veterinarian. In the system includes features such as pet profile management, appointment booking and approval, viewing and updating medical records, notification service, and basic system statistics. This project focused on a mobile-based prototype to ensure the system is easy to access and user-friendly. Next, I will move to chapter 2, which focus on the literature review and analysis of existing veterinary related systems. In this review of existing system, there are several veterinary systems have been developed to support clinic operation. For example, systems such as Smart Vet and Elite Vet mainly focus on appointment scheduling and basic medical record management. Other systems like Vet Care and Livestockly emphasize communication features such as online consultation. However, most existing systems only focus on specific function and do not fully support complete veterinary workflow. Based on the comparison of existing systems, it can be seen that some systems provide appointment booking but lack of medical record updates, while others offer communication features but are not fully mobile based. In addition, features such as role based access and integrated notification are often missing. This limitation highlights the need for a more complete and centralized system which become more direction of my proposed system. The proposed system is designed as a centralized mobile-based veterinarian service management system with role-based access. Pet owner can manage pet profile, book appointment, and view medical records. Vet staff are responsible for approving appointments and managing schedules. Veterinarians can view assigned appointment and update diagnosis and treatment information. Notification service are also included to keep pet owner informed about appointment updates. The main focus of this system is to support practical clinic operation. After that, I will explain Chapter 3, which covers the requirement analysis, system design, and methodology used in this project. This project uses the Software Development Lifecycle or SDLC as the development approach. The waterfall model was chosen because the system requirements are clearly defined and stable. This model allows that the project to be developed in a structured and systematic way, which is suitable for my FYP approach. The SDLC approach provides a clear development structure where each phase must be completed before moving on to the next. This help ensures proper documentation, better understanding of system requirements, and organized development throughout the project. The waterfall consists of clear and sequential phases, making it easy to manage and document. Since the requirements of this system are well defined, this model is suitable for developing of the proposed system in a controlled and systematic manner. During the requirement analysis phase, the target user will identify as pet owner, vet staff, and veterinarian. Data was collected using a Google Form questionnaires, literature review, and analysis of the existing system based on this data. System problems were identified and the functional and non-functional requirements were defined. For this system design, several diagrams were used to represent system functionality and user interaction. These include the use case diagram, activity diagram, sequence diagram, and entity relationship diagram. This use case diagram illustrates the overall interaction between the user and the system. In this system, there are three main actors, which is like I said just now, pet owner, vet staff, and veterinarian. Each actor has different role and responsibility based on their access level. Pet owners are able to register and log into the system, manage their pet profile, book appointments, view appointment status, and access their pet's medical record. Vet staff are responsible for managing and approving appointment requests as well as organizing appointment schedules, while veterinarians can view assigned appointments, update diagnosis and treatment information, and communicate with pet owner. Overall, this diagram helps to clearly define the system boundaries and shows what function each user is allowed to perform within in the system. For these activity diagrams, it shows the step-by-step workflow of the system from the perspective of different users. For pet owner, the activities start with the when the user log in into the system. After successful login, the user can manage pet information, view medical record, book appointments, communicate with veterinarian, and receive notification before logging out. For vet staff, the workflow begins with login, followed by viewing appointment requests, approving or rejecting appointments, managing schedules, and receiving notifications. For veterinarian, the activity diagram shows the process of logging in, viewing assigned appointment, accessing pet medical records, updating diagnosis and treatment details, communicating with pet owner, and finally logging out. This diagram helps explain how the system operates in a structured flow, how each user interacts with the system from start to the end. The sequence diagram illustrates how data and message are exchanged between the different components of this system, which include the user mobile application system and database. For example, in this login process, the user enters their login credentials through the mobile app, which are then sent to the system for validation. The system checks the credential with the database and returns the result back to the user. Similarly, to the pet profile management, appointment booking, and medical records update, the sequence diagram shows how the requests are submitted, processed by the system, stored in the database, and then returned as response to the user. these diagrams are very important because they clearly show how the order of interaction on how the system responds to the user action in a real time. In these sequence diagrams, it illustrates the appointment booking approval process. The pet owner starts by submitting an appointment request through the mobile application. The system is sent to the system and stored in the database with a pending status. Vet staff then access the system to review the appointment request. After reviewing, the vet staff either approve or reject the appointment. The system updates the appointment status in the database, sends a notification to the pet owner regarding the decision. This sequence helps to ensure that appointments are managed in an organized and controlled manner. The while the update medical records, it explains how veterinarian update the medical records after a consultation. The process begins when the veterinarian selects an assigned appointment and access the pet's medical records through the system. The veterinarian then enters the diagnosis and treatment details. The system sends this information to the database to be saved securely. Once the database confirms the update, the system notifies the veterinarian that the medical records has been successfully updated. This ensures that all of the medical information is recorded accurately and can be accessed later by the authorized user. While in this entity relationship diagram, ERD represents the database structure of the system and shows the data organized and related. The main entitles in the system include user, pet, appointments, medical records, notification, and communication. Each user can have a specific role such as pet owner, vet staff, or veterinarian. A pet owner can own a multiple pet, and each of pet can have multiple appointments and medical records. Appointments are linked to both pets and veterinarian, while medical records store diagnosis and treatment information for each consultation. Notification can be used to inform user about appointment updates, and the communication entity supports messaging or calls between the user. This ERD ensures that proper data integrity, reduce redundancy, and support efficiency system operation. In conclusion, this project focused on analyzing and designing a smart pet care and veterinary service management system to solve common problems faced by veterinary clinic and pet owner. Issues such as manual appointment booking, limited medical record access, and inefficient communication were successfully addressed through the proper system design. The system design developed in my FYP provide a strong foundation for the system implementation in FYP 2. In the next phase, the system will further develop and tested based on the design created in this project. That was all conclude in my presentation. Thank you very much for your time and attention.